Greetings everyone. Today we're going to explore factor by grouping, which is specifically used when you have 4 terms. If you have a foldable, now would be the time to get that out. If you do not, my suggestion would be to jump to the end of this slide, write everything down, and then rewind and watch and listen to the explanation. So what we're going to do is I'm going to provide an example. That way you can see the steps worked through. What's awesome about factor by grouping, it's the same steps every time. There's no guess and check. It's sort of do this step, then the next, by the book. So you rule followers are going to like this. Here's my example. Pretty big numbers. So that's really going to push us to always look and see if I can factor out a GCF first. And in this case, the most that I can divide out is a 3. Doesn't seem like much, but I need to factor it out. The second step is you're going to group terms into pairs with parentheses. So I'm just going to leave that 3 alone for a while. But I have 4 terms. I'm going to put the first pair in its own parentheses and the second pair in its own parentheses. What this does is it's breaking it up into pieces to make our lives easier. Because step 3 says factor out a GCF again, but this time from each pair. So 21 and 18. If I take a look at that, what can I divide out of both of those? 3. What can I divide out of x cubed and x squared? X squared. Let's look at the second set. What can I factor out of 35 and 30? A 5. Since they're both negative, I also want to factor out a negative. Now when I factor that out, here's what I'm left with. My greatest common factor is now located right up front. And my factored binomial, right? 21 divided by 3 is 7, 18 divided by 3 is 6, okay? And then my second set, so it's almost like 2 small problems in one. Hey, look at those parentheses. What do you notice? Here's what I love about factoring by grouping is you end up with the same parenthesis. So here's your checkpoint. If you don't get the same parenthesis, stop, rewind, try something else. If you end up with the same parenthesis, you know you're on the right track. So if I have the same thing, I shouldn't have to write it twice. We call this the common binomial. So we're going to factor out the common binomial, which means I only have to write it once, and then I create a new binomial with what's remaining, meaning my 2 factors from earlier create their own binomial. So I always think of it as write the common binomial once, and then write what's left over. Make sure you then write all factors in nice clean parentheses, but also don't forget that 3, okay? That GCF matters. It's got to come down and be in front of your 2 factors. And my suggestion is always going to be, if you can check your work. So what does that mean? That looks like foiling it back out and then distributing the 3 in, or multiplying using the box, whichever method you prefer. All right, so let's work through a couple of examples. If you feel confident on these, my suggestion would be to pause, work it out, and then press play to see if you got it right. If you're not confident yet, then definitely follow along, pause when needed to write down, and then continue. So step 1, factor out a GCF if possible. I don't have a GCF of 2 and 5. I also can't factor out a variable because the 30 doesn't have one. So there's no GCF. Step 2, group the pairs of terms to create 2 binomials. The next step, factor out a GCF from both binomials. So what can I factor out of 2 and 12? 2. What can I factor out of x cubed and x squared? X squared. which leaves me with 2x squared. And let's see what's remaining. Remaining, I would have an x, 2 divided by 2 is 1, x cubed divided by x squared is x, a plus sign, 12 divided by 2 is 6, x squared divided by x squared is 1, so I don't need to write it. Let's look at the second set of parentheses. What's the greatest common factor of -5 and -30? If they're both negative, 100% take out a negative. And then let's see what we have left over. -5x divided by -5 is x. -30 divided by -5 is +6. Did it work so far? Here's our checkpoint. I have a common binomial. So my next step is to factor out the common binomial, or generically write it once, followed by writing what's remaining. If I factor that out, I have a 2x squared and a -5 remaining. Lastly, make sure your answer is written cleanly in 2 sets of parentheses. The order in which you write those parentheses doesn't matter. We didn't have a GCF, so there's nothing to bring down. I can't factor x plus 6. I can't factor 2x minus 5. I could double check by quickly multiplying to make sure I'm right. Okay, you always have that option to check your work. Let's take a look at this example. This one's unique. It is different, so yes, I still want you to jot this down. If you're confident, pause, work it out, and then press play. Otherwise, let's work through this together. First, factor out a GCF. I don't have one. My numbers are 2, 4, 1, and 2, so don't forget there's technically a 1 there. And the 2 doesn't have an x, so I can't factor out a variable. So let's start grouping. Group, hence the name, the pairs of terms. Factor out your GCFs. Okay, what can I factor out of 2 and 4? 2. What can I factor out of x cubed and x squared? X squared. Which leaves me with a 2x squared. And remaining, I will have, let's see, an x plus 4 divided by 2 is 2. There we go, a clean x plus 2. Let's look at our second set. What can I factor out of 1x and 2? Here's why this is unique. Maybe put a star by this one, okay? The greatest common factor, and it's going to seem silly to do this, is 1. Normally that wouldn't be a big deal, but because we're grouping, it matters. So I'm factoring out, and specifically, a +1. When I factor out a +1, I'm left with the x plus 2. So notice the parenthesis doesn't change, but I had to do this so that I have a term out front. You have to have something, okay? So that's why this is unique. Next, I have a common binomial. That's good. Let's factor that out. If I factor out my common binomial of x plus 2, okay, then what I have remaining is a 2x squared plus 1, right? I'm bringing that 2x squared down. I'm bringing that +1 down. There we go. Lastly, we had no GCF to bring down. We've got it cleanly written in 2 parentheses. The order in which you write them doesn't matter, meaning you could write your final answer like this. Multiplication's commutative. And there's our final answer. If you want to double and triple make sure, you could multiply that out using the method of your choice to make sure you arrive back at the original example. All right, let's take a look at one more example. This one is also unique, you'll notice, because it has 2 variables. So first thing we need to check for is a GCF, okay? Well, let's see. I have a 12, a 9, a 4, and a 3. There's no common factor that I can divide out of those, so that doesn't work. Let's take a look at x's. X squared, x, no x. Well, can't divide an x out. And y's, well, the first term doesn't have a y. So we're going to jump straight into grouping our pairs of terms. You got to keep the signs with them. So you'll notice that I'm keeping that negative with the 4. That's where it belongs. Next step, factor out a GCF from each set. So now let's look on a smaller scale. What can I divide out of 12 and 9? A 3. What can I divide out of x squared and x? An x. And then there's only one y, so that's not helpful. So I have a 3x, which leaves me with a 4x plus 3y. 12 divided by 3 is 4. X squared divided by x is x. Bring down the plus sign. 9 divided by 3 is 3. And I got a y hanging out, right? Got to bring that down. Let's look at the second set. What can I divide out of a negative 4 and a negative 3? Just a negative 1. Now you might be thinking, how do I know to take a 1 out? You have to take something out. And because they're both negative, you need to take out the negative. I can't divide an x out because the second one doesn't even have 1, but I can take at least a negative 1y. So when I divide that out, negatives divided by negatives are positives. 4 divided by 1 is 4. I've got an x. Y divided by y, don't have to worry about it. Negative divided by negative, positive. 3 divided by 1. Y squared divided by y would leave me with a y. Here's your checkpoint. How you doing? I got a common binomial. That's good. So let's factor out the common binomial. And my new binomial is based on what's remaining, which is a 3x subtract a 1y. To tidy up, make sure we didn't have a GCF at the beginning, so there's nothing to bring down. It's cleanly written in 2 sets of parentheses. The order which parenthesis comes first doesn't matter. And if you want to double, triple check, multiply those binomials and see if you arrive back at the original question. All right, you guys, so here, I love factor by grouping, and I hope you do too, because it's straightforward. Do this, then this, then this. You're taking what looks to be a big problem, and you're making it into a bunch of smaller problems. So make sure you are comfortable and you work with those steps, okay? We went through multiple examples. Some are unique because of variables or numbers. So next, you want to see what's your practice, what's the assignments in class or on Google Classroom, what do you need there, okay? As always, make sure you check out PowerSchool. How are you doing? Do we have anything to get caught up on? And if you have any questions at all, make sure you visit with me. Let me know. Let's take care of everything. I want to make sure that you understand this. And until next time, have a good one. Hey, are you still watching? If so, rock on. If it's the year 2020, you're watching this from home. So I got a deal for you. The first 3 Algebra 1 students to email me with their mailing address and the code word Backstreet Boys might get something in the mail. Good luck!